Activity of metals. We already know that we find our metals on the periodic table. We know that we can find our metals on which side of the periodic table? Left hand side. No, it's the left hand side. Right, left, yeah. Okay, so the metals that I will be working with today is potassium, sodium, and lithium, okay? Now, these metals, you find them in group 1 of the periodic table. So remember, that's our first column. And these are some of our most reactive metals. We call these our alkali metals. Okay, so now, what you might be able to see, and I'm going to start with lithium first of all, is that actually, these metals are stored in oil. The reason this is because they are extremely reactive. So if they were to not be stored in oil and just left out in the atmosphere, the oxygen that we find in the air would react with the oxygen in the air. Okay, so we store these metals in oil. Right. So I'm working with lithium first of all. So what I have inside this huge bowl that you can see here is just water. I have some water. I'm simply only going to be reacting these metals with just water. So that will show you how reactive these are. The fact that I'm reacting it with this metal with water. Yeah? 1 second. We're using a scalpel, so a knife. No. We've got metals set up for you already. Right, so put this back in the camera, you guys can see. So what you can see, I'm just going to take out a piece of metal. So can you see here? I've taken out a piece of metal. Yep. And let me just, and it's quite, sorry? Is he like a black guy that raps or something? No. Okay. Right. So that's our lithium. That's our lithium metal. Now, just for you to see some of the properties of this metal, do you think it's going to be hard or soft? Do you think I'll be able to cut into that? Right. Lovely. Yeah. So it is a little bit difficult, but I can actually cut into this metal. Yeah. Right. What I'm going to do? Let me just cut another piece because I want a bit bigger piece. Yeah. Right. So I'm not going to put all of it into the water. I'm just going to put this piece, okay? So I'm going to use my tweezers to pick this up, like so. And then let's lift this back. But it can, so not all metals are hard. Yeah. Or like completely hard, should I say. Right, so all I want to do, all I'm reacting is my metal with my water. So at the moment, remember, we're using lithium. So you guys need to hopefully be able to see and observe and write down your observations in your table at the same time. So let's go. Oh, come on. Can you see anything? Amazing. So write down what you observed. Remember, what do you see? Excellent. Can you hear anything as well? Can you hear that fizzing as well? Can see bubbles. Bubbles indicates that there's gas being released. Okay. Lovely. I mean, I don't think you were smiling it, but right, yeah. But you can write down what you heard. If you heard it, but you definitely saw bubbling. You didn't. All right. So let's write what you saw. Right. So one of the products that we should get when we react lithium is water is alkali, so a hydroxide, which is an alkali. So here I have what we call universal indicator, and what should happen is that if I add some of this universal indicator, let's focus that, if I add some of this universal indicator into my trough of water, if this turns purple, that means that the alkali product was present, yeah, from the lithium. So let's see. Huh? No, let's. What's happening? Let's see. It's turning purple, yeah. So this is universal indicator, yeah. So this. universal indicator. So this indicates that there is an alkali present. The fact that it's turning purple. What this actually links with, and I know you haven't learned this yet. At some point you'll learn it either in year 8 or at the end of year 7. If you look up there in the ceiling, it goes in line with what we call the pH scale, yeah? So here you see these colours here representing the fact that this is the colour if something is acidic. If something is alkali, it's going to be bluey, purpley, yeah? That is alkali, that is the alkali present.
What is red?
Then it's acidic.
The morph is green.
Then it's neutral. Right, lovely.
We are alkali present.
Alkali is present, yeah, it's present. And alkaline is present, yes, you said that correctly. Right, lovely. Let's go to our next metal quickly so you guys can go ahead and do your own thing. Right. So, we're moving on to our next metal. Oh, let's look at this. Lovely. Who remembers what the chemical symbol for sodium is?
Na.
Wonderful, well done, good memory. Right.
So 1 minute late. 1 minute.
1 second. 1 second.
Same thing. Sodium stored in oil because we know it's extremely reactive. I'm going to take a piece of sodium. Do you think I'll be able to cut into this?
Yes.
Let's see. Let's see. You're doing it different, but your metals are already ready. Wow, so if you notice, that was a lot softer. So you could write that observation down. Look. And can you also see it's a lot shinier as well on the surfaces? Yes? So what I'm going to do now, this is now, remind me what period sodium was in the periodic table? Group 1, but which period?
Group 1.
Right, lovely. I love that. Lovely, excellent. Right, let's see what's going to happen with the reaction here. Get ready. Oh, sorry guys. Can you look? And can you see that it's happening a lot faster? Oh, sorry. I'll do that again for those that didn't see. Right. Let's do a bit more. Let me do sodium again for everyone to see. Is it on the water? Right, so make sure you're watching. Immediately. So so you see now, you can write the observations that immediately. So it was a lot quicker this time, wasn't it? A lot more vigorous. Use the word vigorous in science, yeah? Right, now for our next alkali metal, potassium. Who knows the chemical symbol for potassium? Who remembers? Not P. No. You guys have potassium. I do. Remember, I'm working with the alkali metals in group 1. Right, someone tell me, what's the chemical symbol for potassium?
PM.
Not PM. Look at your periodic table. No one needs to be guessing. Look at your periodic table. Who just said that? Well done, Zara. Yeah? Excellent. Right. Once again, our potassium is stored in oil. You guys are doing iron. Okay. Right. We're not doing all of them, we're just doing the first 3 and you'll see why in a moment. Right, so again, remember we're looking at how reactive these metals are. So now I'm just going to show you some potassium. Put that down over there. Do you think I'll be able to cut into this?
Yes.
No? Some say yes, some say no. Even softer, yeah? Did you see how, oops, let's bring that back.
It was so easy.
It was very easy. Right, guys. Now, let's set up a final. Let me change the water. So our first one, lithium, was quite reactive. We saw that, we saw some bubbles. Then we saw sodium, and it was even more reactive. We saw how quickly it was a lot more vigorous. What do you guys think is going to happen with potassium?
It's going to
not for this one.
a lot more, and it's going to be rather bulky.
It's going to bubble a lot more, yeah? Okay. Let's see if you guys are right. Yes.
Mrs.
No, it's not a good idea. Right, everybody ready? Let's go. I'm joking, guys. That's what's meant to happen. Write down your observations. Right, are you ready to see the reaction between potassium and water?
Yes.
Let's go. Let's go.
Fire. That's an explosion. What's happened? It went
Wonderful. Let's go. This is to protect. Right, excellent. Well done.